model of atom. This model is described or given by Bohr, the scientist. He had given this model in order to eliminate the drawbacks which are given or which are done in the Rutherford's model. That means he was trying to improve that Rutherford's model, right, in order to decrease those drawbacks. That is, the drawback what we learned in Rutherford model is the atom will be unstable because of the electrons rotating, and they will be radiating the energy, and thus they will be losing the energy and they will be collapsed, right? But according to this Bohr's model, he is saying that the electrons will be rotated in certain orbits or in a certain levels that are known as discrete orbits, and these discrete orbits are known as, that is, say, I have shown here in two circular forms inside the atom. These are known as discrete orbits, and he says that the electrons which are rotated in these discrete orbits does not radiate the energy during the acceleration, because he is saying that previously I have said the electrons will be rotating and they will be accelerated, and thus they will be radiate energy. But he says that the energy will not be radiated when the electrons are rotated in these specialized discrete orbits. Therefore, the energy will not be lost, and thus the atom will not be collapsed, and the electrons does not fall into the nucleus, right? By this, he says that discrete orbits are also known as shells or discrete shells, and these discrete orbits or shells will contain some energy levels. That is, the orbit or the shell which is nearer to the nucleus will be having more energy, while comparing to the nucleus or shell which is far away from nucleus. That is, for example, take sun. The planet which is nearer to the sun is Mercury, and the Mercury will be having more heat, right? It feels or it having the sensation of warm or heat more, right? The planet which is farther to sun is Pluto, right? And it will be having less. Therefore, the Pluto will be so coldest. We will be saying that because no heat there is no temperature and nothing. By this we can say that the energy also will be differentiated as the temperature varies from the sun towards the planets. At the same time, the nucleus and the electrons which are nearer to the nucleus will be having higher energy levels, rather than the electrons which are farther to the nucleus will be having lower energy levels. By this he says that it can be represented, those energy levels can be represented from starting K, L, M, N, O, P, all these alphabets or letters, and also he has given the numbers. The representation form is N equals to first shell, second shell, third shell, etc. so on. And he also says that one more atom or one more subatomic particle is there in an atom, that is neutrons. J. Chadwick, another scientist, has identified one more subatomic particle, that is neutron, in an atom in 1932. That is, he says that the mass of the neutron is equal to the mass of proton, and the mass of neutron is equal to or 2000 times more than the mass of electron. And he also says the neutron doesn't have any charge because it is neutrally charged particle or no charge particle. And he also says except hydrogen, the gas hydrogen, except the hydrogen gas, every atom or every particle will consist of neutrons, and the neutron is represented in the form of small n. And he says that neutrons are presented all over in every particle, and they are chargeless and there is no assumptions regarding that, because it is obviously zero, so no effect of neutron will be acted on proton or electron or in an atom. Thus, he says in order to find out the mass of an atom, we have to add all the masses of these subatomic particles, that is the masses of proton, electron and neutron. Electron we have said already it is negligible because we are not considering it because it is having less, and we will be considering that proton mass and neutron mass, and and we will be calculating the mass of atom. Now we are taking the mass of atom as 2 because the mass of proton is taken as 1 unit and the mass of neutron is taken as another 1 unit, and that 1 plus 1 equals to 2 units, as the basic mass of an atom is 2. And now let us see how the electrons are distributed in different orbits or shells. That is, how many electrons are distributed in each orbit or each shell in an atom. Now according to Bohr and Bury, that is Bohr's model and Bury's model, according to them, they say that all the 4 rules in order to have the maximum number of electrons in a particular shell. That is, in first rule is, that is, maximum number of electrons in a shell is 2n square. The formula given as 2n square, because 2 I said, that is the mass of an atom, is basic mass is 2 units. So therefore they are giving 2 into n square. N is the level of discrete orbits or discrete shells. Therefore n will be equals to 1 for first orbit, that is K shell, that is 2 into 1 square equals to 2, and for the second orbit shell, that is L shell, it will be given as 2 into 2 square, that is 4, and 4 2s are 8, and therefore third orbit, that is N shell, will be consisting of 2 into 3 square, that is 18, and fourth shell, it will be N shell, that is 2 into 4 square equals to 32. Maximum number of electrons equals to 8 outermost orbit, that is the maximum number of electrons that can be filled up in a last shell is only 8 electrons, and the inner shells to be filled, because in order to fill an orbit or shell, the innermost shells should be filled first, then only the outermost shells will be filled up. That is the order-wise or stepwise manner which is going on in the filling up of electrons in the discrete orbits or discrete shells of an atom. Now we will be seeing that atomic model displaying the first 18 elements. Let us see how the atoms within the electrons or protons, how they are situated or how they are placed within an atom for the first 18 elements. We will be seeing those 18 elements and how they are represented. See the atomic structure of the first 14 elements. That is, let us take the first element, hydrogen, and the discrete orbit for the hydrogen element is 1, and it is known as K shell or first orbit, and the electrons will be equals to 1 for hydrogen, and it is placed on the first orbit of the shell. Now let us see for the element helium, that is second element, that is it consists of 2 protons, 2 neutrons and 2 electrons. That is, it is known as an inert gas because the orbit or the shell is completely filled up with the maximum amount of electrons. Therefore, it is known as inert gas, and the number of neutrons for the first atom, that is hydrogen, is 0 because the hydrogen gas only the element which does not have the neutrons. And let us take the third element, that is lithium, and it consists of protons 3, neutrons 4 and electrons 3. And always remember that protons and electrons will be in same, and they will be with opposite signs, and they will be balancing the stability of an atom. Whereas coming to neutrons, it will be plus 1 for every element, right? Now let us take beryllium, that is fourth element. It will be consisting of 4 elements, that is protons and electrons, and 5 elements of neutrons. And similarly for boron, carbon, nitrogen, oxygen, fluorine, neon, all these elements will consist of 2 orbits or 2 shells, that is first shell is K and second shell is L, and also it is represented as first orbit and second orbit, and any orbit consists of maximum of 8 electrons only, and this is therefore and this is shown in the figure as, that is for carbon we have 6 electrons, 6 protons and 6 neutrons, and for nitrogen it is 7, and for oxygen it will be 8. And the valency electrons is defined as the electrons which are residing or which are in the outermost shell of an atom. That is, for example, take lithium. The lithium has two shells, that is first shell and second shell. When the first shell is completed, then the electrons will be further placed in the outermost shells, that is second shell. In second shell for lithium we are having only one electron, right? Therefore the valency electrons for lithium is 1. By this I have previously said that protons can be combined or concentrated in the middle of the atom, that is we will be knowing as nucleus, and these electrons will be on the outermost parts of the atom. By this we can say that an atom or an element attains the stability by sharing or losing or gaining the number of electrons. They will be attaining the inert nature or the fullness or filling up of the orbit by losing or gaining the electrons from each other. That is, the lithium can lose the electron, that is one valency electron from it, and thus it can attain the stability nature or inert gas nature, right? And at the same time, for suppose let us take this nitrogen. Nitrogen is having 7 electrons, right, almost, but the second orbit it is having 1, 2, 3, 4, 5. 5 electrons in the second orbit. And for oxygen it is 6 electrons in the outermost shell. And for fluorine it is 7 electrons in the outermost shell and 2 electrons in the innermost shell, that is K shell. Now this fluorine will be attaining the inert gas nature, that is of neon, by accepting or gaining 1 electron. That is, from beryllium it can accept 1 electron and it can attain the nature of inert gas, and at the same time beryllium by losing 1 electron it can attain the same inert gas nature or stability. Thus the electrons or the elements will be attaining the stability nature by losing or gaining, and we will be seeing that up to silicon I have written the atomic structures of elements, and we can proceed on for phosphorus, sulfur, chlorine and argon. And the inert gas natures means the completeness of shells, that is the how many maximum number of electrons that will be filled in outermost shells is 8. The electrons or the elements which are filled up with the 8 electrons in the outermost shell are known as inert gas elements, and they are known as helium, neon and argon. And we will be seeing the combining capacity of these electrons and the valency nature